Hi guys, in this video we're going to be talking about section 881. And so we are going to be solving radical equations. And so these are basically the two steps that we want to do. We want to isolate the radical. And then we're going to solve by doing inverse operations. And then at the end, we just need to make sure we check for extraneous solutions, so those solutions that don't satisfy the equation. Okay, and then this is important. We cannot take even roots of negative values. Okay, so here, the cube root of x is the radical piece, so we are going to add 2 to both sides first. So then I have the cube root of x equals 2. So to undo the cube root, we are going to cube both sides. So x is equal to 2 cubed, which is 8. If I were to plug 8 back in, cube root of 8 is 2, 2 minus 2 is 0. So just basically we want to make sure we are checking solutions, especially when I get anything negative. Okay, here, now this one I have 2 different cube roots, but if I have a cube root on each side and I cube both sides, that'll get rid of the roots, of the radical, excuse me. So I'm going to add this cube root of x to the other side. So I'm at cube root of 2x plus 1 is equal to the cube root of x. Okay, so now when I cube both sides, that'll get rid of the cube root. So I have 2x plus 1 is equal to x. Okay, I'm going to get my x's together, so I'm going to subtract x over here. So I've got now x plus 1 equals 0. Subtract 1, I get x equals negative 1. Okay, so we should be okay here because these were both odd roots, not even roots are really the ones we have to check. But if we were to plug negative 1 back in, 2 times negative 1 is negative 2, plus 1 is negative 1. So it's saying the cube root of negative 1, does that equal, or excuse me, minus cube root of negative 1, does that equal 0? Cube root of negative 1 is negative 1, cube root of negative 1 is negative 1, but then I have that minus a negative, so that changes it to plus. So negative 1 plus 1 is 0, so that solution checks out. Again, if you have an odd root, you should be fine with negative values. You can still check to be sure, but it's really with square roots that we need to check. So here is an example of one in particular that I'm really going to need to check my solution. Okay, so this one, I have a square root on both sides. So to get rid of that radical, we're going to square both sides. This one, we do have a piece that's outside the square or the radical. I need to square that as well. So I'm going to get 7x plus 2 equals 3 squared is 9. And then this squared gets rid of the radical. Okay, so now I'm going to distribute my 9. So I've got 7x plus 2 equals 27x minus 18. Get my x's together. So I've got 20x minus 18 equals 2 after I subtract 7x. Add 18. So 20 equals 20x. X equals 1. Okay, if we check this, so 7 times 1 plus 2 is 9. Here, 3 times 1 is 3, minus 1 is 1. So we're asking, does the square root of 9 equal 3 times the square root of 1? This one does. So that means x equals 1 is a solution. If we put it back in and we get something that's not true, then this would be a no solution scenario. Okay, here, so this is an example right now. Actually, guys, I can say this is no solution. It is not possible for a square root to equal a negative value. But let's say you didn't notice that right away and you go to square both sides. Okay, so I get x equals 1. So then if I plug 1 back in, square root of 1, does that equal negative 1? That is not true. Square root of 1 equals 1. So this means no solution. Okay, this one is cube root. Again, I want to isolate the radical part first. So if I can get rid of the 7, I'm going to. So I'm going to divide both sides by 7. And I get 12 there. So we've got cube root of, yeah, okay. 5x minus 7 equals 12. So now to undo that radical, we're going to cube both sides. So I've got 5x minus 7 equals, and not sure what 12 cubed is off the top of my head. Pull off calculator here. Okay, so we have 12 cubed, which is 1728. Add 7. 1735. Divide by 5, we get 347. Okay. All right, I guess I don't have a number on this one. This one, okay. All right, so to undo the radical, I need to square both sides. Right now the radical is isolated, so I don't need to do any movement. So when I square this, I also need to square this side. So I've got x, right? Squaring and square root will cancel. X minus 6 squared, remember that means x minus 6 times x minus 6. So this is where I distribute twice. So x times x is x squared. X times negative 6 is negative 6x. Negative 6 times x, another negative 6x. Negative 6 times negative 6, positive 36. I'm going to combine some like terms, but because I have a quadratic, I'm going to set it equal to 0. So I'm going to subtract x over here. So I've got 0 equals x squared, let's see, minus 13x, when I put all those x's together, plus 36. Okay, so I could solve using the quadratic formula, completing the square, or factoring. This one factors nicely. X minus 4 and x minus 9. So then x equals 4 or 9 would be my solutions. Now I need to check. This was an even root up here. Possible I have some extraneous solutions. Okay, so first let's check 4. So we're asking, does the square root of 4 equal 4 minus 6? Okay, so square root of 4 is 2. 4 minus 6 is negative 2. Those are not equal. So this means 4 is extraneous. Okay, let's check 9. So square root of 9, does that equal 9 minus 6? 3 equals 3. Yes, so 9 is our solution. So x equals 9 is the only solution for this problem. Okay. All right, the next thing we're going to do here, guys, is we're still solving radical equations, but we're going to have things in exponential form first. So basically what we want to do is we want to get the part that has the exponent by itself, okay? And you want this to equal 1. So I am going to multiply this to the 3/4, because if I do, I would get 12 over 12, which is 1. So multiplying by the reciprocal, or applying the reciprocal, I should say, is going to get x by itself. Now I need to do that to both sides. Okay, so this is going to equal x to the first, which is just x. And remember, this is the same as the 4th root of 256 cubed. Okay, that's another way to think about that. Okay, 4th root of 256, I believe, is 4. Check my math here. Yep, is 4, and then 4 to the 3rd is 64. Okay. All right, and this was an this was an even root. Good idea to check. So we're asking ourselves, does 64 to the 4/3 equal 256 to the 3/4? Okay, if we put in 64 there, cube root of 64 is 4, 4 to the 4th is 256. So we do get the same thing there. Okay, so I want to get this part by itself, so I'm going to add 12 to the other side. And I'm also going to divide by 3 because the exponent only is applied to the x. Okay, so now I want to get this to equal 1, so I'm going to apply the reciprocal exponent. Okay, so I get x equals, this is the same as square root of 4 to the 3rd. Okay, square root of 4 is 2. 2 to the third is 8. Okay, if we check it, so I'm checking 3 times 8 to the 2/3 minus 12, does that equal 0? So cube root of 8 is 2, 2 squared is 4, 4 times 3 is 12, 12 minus 12 is 0. Okay? All right, this whole thing is being applied to the 1/2. We want to make that equal 1, so we're going to multiply by the exponent reciprocal. Apply that to both sides. So 2 over 1 is just 2, right? So I now have 2x plus 15 equals x squared. I have a quadratic, so I'm going to set it equal to 0. So we've got x squared minus 2x minus 15. This one factors nicely. X minus 5, x plus 3. So I'm going to get x equals 5 and negative 3. So let's check. Okay. If I put in, I'm especially going to check this negative. If I put in negative 3, so show that over here. So if I do 2 times negative 3 plus 15, oh, actually, I think we might, oh, yeah, okay. Does this equal negative 3? Okay, so if I put this in here, I get negative 6 plus 15 is 9. 9 to the 1/2 equals positive 3, not negative 3. So this means this one is extraneous. If we do the same thing for 5, I think we're okay. Because I'm going to get 10, 25, square root of 25 is 5. So we do get 5 on both sides, so x equals 5 is the only solution. Okay, last two here. Okay, again, I want to get the x with the exponent by itself, so I'm going to add 108. Divide by 4. And 108 divided by 4 is 27. Okay, so now I'm going to apply the reciprocal exponent. Okay, so this is cube root of 27 to the 4th. So you get 3 to the 4th, which is 81. Okay, all right, if I plug 81 back in, cube root of 81 is, or I should say 4th root of 81 is 3, 3 to the 4th is 27, times 4 is 108. That one checks out. Okay, this one, apply the reciprocal. So this is going to become 4x squared. Here we're left with 4x plus 8. Set it equal to 0. All right, and this one, I have a value that's not 1 in front, so I'm going to take out a 4 out of everything here. Okay, so then I can divide by 4. So I've got x squared minus x minus 2 equals 0. Factor. Numbers that multiply to be negative 2 and add up to be negative 1. Negative 2 and positive 1. All right, so we have a negative value, especially helpful to check. Okay, so I'm going to check the negative. So 2 times negative 1, does that equal 4 times negative 1 plus 8, and then square root of that. Okay, so I get negative 2. Here I get negative 4 plus 8 is 4, which is square root of 4 is positive 2. So this one is extraneous. If we were to put 2 in there, 2 times 2, 4 times 2 plus 8, and then square root. So I get 8 plus 8, 16. Square root of 16 is 4, so I get 4 equals 4. So 2 is the only solution. 1 is extraneous. Okay, and that is it for the video today, you guys. Thanks for watching.